Hello, my name is Ondřej and I would like to introduce you our Ontology Visualization Tools Recommender. This tool can help you to find the most appropriate ontology visualization tool for your use case and your ontology. This tool is based on Nest expert system, which has functionality of traditional compositional rule-based expert system with uncertainty handling in a standard range between -1, which means certain false, and +1, which means certain true. We use a larger interval, -3 to 3. So this web page, this tool is basically a web application which has tailored web page, and it collects important information for the recommender. So there are 4 types of questions. The first one is about OWL features. So the user can say which OWL features are important for the user and how much on the range -3 to 3. So for example, let's say that complex classes are very important for us, and also property characteristics are very important for us. On the other hand, for example, object properties are not very important with sure, and interclass relationships are not very important, but it's not so sure. So for example, let's set -2. The second type of question deals with preference of ontology development environment. Currently, we include 3 of them: Protege 3, Protege 4, and Neon Toolkit. So let's say that the user is familiar with Protege 4, so let's set 3. But for example, Protege 3, the user does not want to use Protege 3, so -3. And the user is unaware of Neon Toolkit, so we will leave 0. The third type of question deals with intended usage. So there are 8 intended usage for ontology visualization. So for example, we can say that we want to use ontology visualization for making screenshots, for reusing ontology, for developing a new ontology, for analyzing mappings of the ontology. So we can set, for example, we can say that we want to use making screenshots for sure. On the next, we want to analyze mappings of the ontology, but this is not the main use case for us. So for example, just 2. And for sure, we don't want to use checking domain inconsistencies and checking structural inconsistencies. So -3 to both of them. Finally, we can say how large the ontology is. There is maximum 1001. If the ontology is larger than this, we always set just only this number, 1000 actually. So let's say that we want to visualize ontology which is not very small, but it's not also very large. So for example, 250. Then we can move to the recommendations. So then we can wait for some time, and now we see first there is summary of our input, and then there is recommendation from the recommender. So the first, the ordered list of ontology visualization tools, where you can always click on each ontology visualization tool and it will take you to the home page of the ontology visualization tool. So the first one is key series, the second one is Ontodia, and the third one is Ontograph. Then you can revise your answers and try it again. So basically, this tool is just front end for the recommender, and the recommender backend is based on the Nest expert system. And I would like to introduce you our extensions. So the first extension is because the expert system works with knowledge base, so we had to create first knowledge base about ontology visualization tools. So we extended this knowledge base with three ontology visualization tools, which are new one. So the first one is OntoDR, the second one is WebWow, and the third one is Graphu. So this is our first extension. The second extension is in the first part of the web page. So it's this part about inspecting features of particle ontology. The idea behind is that there are different types of questions, 4 of them, and we think that some of them can be computed automatically, or at least they can be suggested for the user, and the user can change them, but he or she can also use the pre-computed weights. And we think that this is true about all features. So if the user has some existing ontology in mind, then he or she can upload the ontology here, and this is the new feature, and the tool will compute not only values of ontology metrics, but also it will assess the answers for these questions about all our features. So this is the first partial automation, and the second partial automation is about, of course, ontology size, which is clearly a good candidate for this type of automation. So let's try some example. For example, Fabio ontology. So just copy and paste, and then we also have to select in which context the assessing importance weights will be computed. So we use different ontology pools from our another ontology tool, OOSP tool, which means online ontology set picker tool. You can find it you can find its main web page and you can use it. So for example, we will select this collection, OntoFarm collection, which is collection about containing ontologies from conference organization domain, and there are not very big ontologies. So this is like context, and we can compute assess important weights with regard to this collection. So I will explain it a little bit later. Now it's working, and now we can see ontology metrics which are important for us, and also we can see important weights which can be always changed by the user. So we can see that within the context of OntoFarm collection, complex classes in Fabio ontology are important, but not so much. It's very similar as with interclass relationships. In the opposite, object properties are not very important, but what are very important are data type properties. And property characteristics are rather neutral. So this is computed, and the user can use it directly. So this is kind of support for the user, and of course also size. So we can leave the answers as before, and we can also see size, which is computed also. So then if we press the next button, then we can see recommendations, and it's again key series as a recommendation number 1. With regard, we should also explain a little bit how we compute, how we assess the important weights. So it is based on min-max normalization. So we use minimum and maximum numbers of ontology metrics from collection that we select. So if we use, for example, bioportal, then it means that if we just choose back, so we can also use bioportal, and we can expect that there are larger ontologies. So for example, Fabio, and then bioportal or linked open vocabularies. So we click on inspect ontology, and then it should be reflected on with regards to resulted important ways. So just check them. So yeah, and we can see that everything is almost not important because bioportal ontologies are quite large in all of those aspects which are mentioned here. So it's always almost -3 for each of those OWL features. So this is based on this equation. The result is range between 0 and 1, but we then rescale it into the range between -1 and 1 in order to be in line with Nest expert system. So this is another extension, and the final one extension is rather integration of our Ontology Visualization Tools Recommender into our USP tool, which is online ontology set picker tool, and you can find screencast and you can find this tool on the web page. So it's the same link, but there is just only OOSP instead of this OVTR. So thank you for your attention. If you have any question, you can contact me via email, and goodbye.